Okay, so we have to be careful. Not all vector spaces are finite dimensional. So let's see an example here. So we've seen P1, P2, P3. Let's think about P infinity, okay, where we don't put a limit on the degree. Well, what's in there? Well, the one is in there. What else is in there? T. T is in there. T squared, T cubed, T4, T5, T to the 6, T to the 7, and so on. So there is no finite basis. Let me talk a bit more about this. So 1t, t squared, ... This infinite set is independent. Maybe I should start. Let's just be more careful here. Let's see, I go t to the n is independent for all integers n bigger than 0. So there's going to be a finite basis. Okay, so you guys are talking about infinite, but we will not do so, of course. But we'll just, I guess, say that the dimension here is infinite. Okay, we're not going to talk about infinite dimension cases in this course. So I want to just point out that okay, let's return back to the finite dimensional world and do a couple examples of finding dimension. So pause and copy. So I want to find dimension here. So what I should do is first of all find a basis. So let's do a technique which I will do a lot in the coming lectures. I assume that I have something in H, and then I start a little argument here. So if X is in H, so Y is equal to 2X. So that means that X, which equals XY, is actually X, 2X, which is X, 1, 2. So what have I found here? I found that if I have something in H, it is a linear combination of this vector here. So my vector X is in the span of, span of this single vector. So it looks like this finite set is our candidate. Candidate for the position of basis, or basis for H. So what do I want to say here? So B, so we'll say this spans H. So B spans H. The last thing to check is that B is independent. We'll do that in red again. Oh, I changed my red. There's a variety of reds here. I'll just say it's clear, right? It's clear. That's still a different red. Oh, well. It's clear that B is independent. Okay, it's a single, it consists of a single non-zero vector. Therefore, B is a basis for H. And B consists of a single vector, so therefore dimension of H is 1. Okay, so I found my argument in blue right here tells me that B spans H. I just state the obvious, that B is independent, and that's it. So B is a basis, it has one vector, so dim H is 1. What's the next one? Next one is, I'm looking at vectors of this form in R3. Okay. I do a similar argument. If I have one of these vectors, let's see if I can write it down. Don't make a mistake. 2y plus 3z. What's the next? Sorry, I'm scrolling up and down. Y plus z is the next entry. Y plus z and then x plus z. So if I have a typical vector in H, I can pull it apart, right? Like so. So this argument in blue, this little tiny calculation in blue, allows me to conclude that B, which is the set of these three vectors, spans H. Now, is B independent? No, unfortunately, it is not. Okay, so let's write that. Is B so how can I check that? Well, you can check by throwing this into a matrix. And reducing. There was a, oh, right. Okay. 1, 2, 3, 0, 1, 1. So subtracting it, -2, -2, giving me 1, 2, 3, 0, 1, 1, 0, 0, 0. So I'm missing a pivot, so this set is dependent. If I go a step further, I can see that, therefore, what can I see from this? Well, I can see that this third column is 1 times the first column plus 1 times the second column. Okay, maybe you saw that from the beginning, which is okay. You can save yourself some time. Okay, so therefore, as we saw before, third column, or third vector here, is a linear combination of the other two. So I can remove it. I can remove it. I can just go up here and go scratch this out. And this statement here will still be true. So I'm actually going to write, let's call this B1, which is equal to just the first two vectors. Spans H and is independent. How do I know this set of two vectors is independent? Well, I just look at what happened right here. Okay, if I ignore that, I have pivot for every column, right? So I got pivot for every column right here, telling me that these two vectors are independent. So it's a basis for H. Therefore, dimension of H is